Good afternoon, students. So, in the previous video, we were talking about the reaction of metals and non-metals with oxygen. So, in this video, we'll be talking about the reaction of metals and non-metals with water, with acid and base. Okay. So, first, uh, now we are going to tell about the reaction of water with metal. So, when a metal reacts with water, then a metal hydroxide is formed. Then hydrogen gas is evolved. So here the metals or most of the metals will be reacting with water, but the reactivity will be depending upon the metals. So here we are some example is given. That sodium is there, magnesium is there, and zinc or iron is there. So the sodium is a highly reactive metal, so that it will be reacting with even the cold water. It will be reacting highly or violently with even the cold water. But magnesium is comparatively less reactive than this sodium, so it will react very slowly only in cold water, but when it is boiling water it will be reacting fastly or rapidly it will be reacting. Then in the case of iron or zinc, these are the metal which is more even less reactive than this magnesium, so it will be reacting slowly with the steam. And the steam is the highest enthalpy and all that we already studied. That means if we are considering about the properties of this liquid, or the usually the steam will be highly reactive than this hot water than the cold water. That means steam is higher than hot and cold water, then next hot water is more reactive than this cold water. Okay, so and the metals like copper, silver, and gold are unreactive. So the metals like these copper, silver, gold are unreactive, and they do not even react with water or even with the steam. So sodium metal is here. One equation is given: sodium plus water gives sodium hydroxide plus hydrogen. So hydrogen gas is evolved. So thus the gas liberated when the sodium metal is hydrogen. So the hydrogen gas is evolved. So here is one activity. In this activity, it is doing that the sodium is put into a beaker which is having water, so that it will be burning and hydrogen gas is evolved. So if we test this solution in the beaker with red and blue litmus paper by one, we will find that it turns red litmus to blue. This shows that the solution formed by reaction in sodium is basic in nature. So water plus sodium gives sodium hydroxide, which is a base. This observation can be explained: sodium metal react with water from sodium hydroxide and hydrogen gas. A lot of heat is produced in this reaction, so it is exothermic reaction. This heat burns hydrogen gas as well as sodium metal. The burning of hydrogen gas causes a little explosion, so formation of hydrogen makes the solution basic, and the solution turns red litmus to blue. Okay, so this is the activity in which what happens is we are burning so that the hydrogen gas is burned. Hydrogen is a good fuel, so it is burning, so it produces heat. Then it is a vigorous highly reaction. It's a exothermic reaction, so this sodium will be turning to sodium hydroxide, which is a base. Okay, so sodium is a very high reactive metal. It reacts with moisture, oxygen, and other gases in the air. So sodium metal is kept exposed to air. It will be various compounds of, so it is kept inside the means under the kerosene. So the sodium metal is kept safe inside the kerosene. Okay, so non-metals do not react with water. We studied metals will be reacting with water. That means in some metals will be reacting with cold water, then some hot water, and some with the only steam. So here is the classification of metals, but non-metals do not react with water. Example, sulfur is a non-metal which will not be reacting with water. In fact, some of the reactive non-metals are kept under water to protect. That means non-reactive metals means these metals will be reacting with air. So for that protection, we are using water as the protective layer. That means it will be separating these metals and air. Okay, so it is kept in the water. If phosphorus is kept open in the air, it reacts with oxygen, catches fire. So it is kept in water. So phosphorus is kept inside the water so that it will not be contact with the air. So we can avoid that reaction. The next one is reaction with acids. So most of the metals react with dilute acid to form salt and hydrogen gas, most of the metals. So it is not telling all the metals. So it is not telling all the metals. So most of the metals react with dilute acids to form salt and hydrogen gas. So metal plus acid gives salt. Mm. Salt and hydrogen. So only the less reactive metals like copper, silver and gold do not react with dilute acid. So only less reactive metals will be not reacting with this dilute acid, but always means almost all other metals will be reacting. So this the vigor of reaction metal with dilute acid depends on the chemical reactivity of the metals. Depending on their reactivity, some metals are react violently, that we know, like sodium, which is a highly reactive metal. Then with dilute acid, some metals react with dilute acid only on heating. So some metals will be needed heat for that reaction, because it is, even though dilute acid requires some amount of temperature, then only it will be reacting. This reaction of magnesium metal will dilute hydrochloric acid is given below. So one example is there: magnesium metal reacts with dilute HCl to form magnesium chloride and hydrogen gas. So when a metal is reacting with acid, magnesium chloride salt is formed and hydrogen gas is evolved. Hmm? So aluminium, iron, zinc metals also react with dilute HCl to form corresponding metal chlorides and hydrogen gas. The hydrogen gas burns with a pop-up sound. We know that when we are placing a candle near this hydrogen gas coming area, then we can hear a pop-up sound. It means that indicates that it's the gas evolved is hydrogen gas. That less reactive metals like copper, silver, gold do not react with dilute acids. So if it is highly reactive metal only, it will be reacting with dilute acid. If it is a low reactive metal or less reactive metal, it will not be reacting with these dilute acids. So like dilute HCl or dilute sulfuric, thus copper, silver and gold do not produce this hydrogen gas. So if it is reacting only, these chlorides are formed. That means if you are adding HCl, the acid metal plus acid, HCl metal chloride. So if it is sulfuric acid, then metal plus sulfuric acid, metal sulfate. So this salt are only found when it is reacting. If they are not reacting, if it is a less reactive metals, then they will not react and they will not produce this hydrogen gas. Okay. So here is one activity that we are taking some iron fillings in one test tube. Then okay, we take 4 test tubes. That means in first one we are taking magnesium ribbon in the first, and the second one aluminum foil in the second test tube. Some in third one some iron fillings, and last one copper. So copper is a less reactive and all others will be reacting. And what happens is, in the three case we can obtain hydrogen gas, in the fourth case there is no hydrogen gas. Then how we can identify hydrogen gas? Then when reaction starts, we are bringing a candle, light and candle, so it will, we can hear in the first 3 test tubes a pop-up sound, but in the fourth case there is no pop-up sound, because the reaction is not taking place, or we can say that it is unreactive. So copper metals also do not does not react with dilute sulfuric acid to produce hydrogen gas. Copper metal, however, react with hot and concentrated sulfuric acid, but now hydrogen gas is produced. Okay, that we will be studying in the higher class. Okay, so understand, copper metal will not react with this dilute HCl. If it is hot and if it is concentrated, not dilute, if it is concentrated and is heated, then it will be reacting, but that we don't have to study now, we will be studying in the higher class. Then the reaction of metals with acid have some important implications in our daily life. So in our daily life we use citrus fruit, then oranges, pickles, etc., which are having acid or which are acidic. So our these reactions with metals and acids have we have some applications that we are using our day-to-day life. Okay, so that means we are using aluminum utensils or copper utensils like that, so we can understand which if it is, it will be reacting or it will not be reacting like that. We means if we are using copper, it is good because it is unreactive metal. Okay, so like that it is important for us. Then mm, kept in when foodstuffs containing acid are kept in iron, aluminum or copper contains the acid present. These metals will contain slowly form toxic, and this toxic can okay. So iron, aluminum and copper utensils should not be used for store acidic foods like citrus juice, because this iron, aluminum and copper containers will be slowly reacting with this acid. Hmm? So it is telling that never use or try to avoid maximum usage of this aluminum, copper and iron utensils, because it will be slowly reacting with these acids. So avoid keeping pickles, chutney, curd, etc. in that utensils. So we cannot store lemon pickle in an aluminum vessel. This is because the acid present in the lemons will be reacting with aluminum metal to form toxic salt. Okay, so it can make us sick or damage our health. So non-metals, about next one is about non-metals. So non-metals do not react with dilute acids. So almost all metals will be reacting with dilute acid, then some metals will be reacting with only concentrated acid and it requires heat, that we studied. But non-metals do not react with dilute acids. So example, we take some sulfur powder or charcoal powder in a test tube and add HCl, dilute HCl. No reaction is taking place on heating also. So you can confirm that no reaction is taking place, or HCl will not react with non-metals. The next one is reaction with bases. So some metals react with bases to form their salt and hydrogen gas. Here also this hydrogen gas is evolved. So metal plus base give salt plus hydrogen, or metal plus acid also is salt plus hydrogen. So here is one example is given, sodium hydroxide, aluminum plus sodium hydroxide, sodium aluminate is formed, then hydrogen gas is evolved. So here is an example, hydrogen gas is evolved. So hydrogen gas is evolved here. So here is one activity given. We can demonstrate the formation of hydrogen gas, which is when this aluminum metal is reacted with sodium hydroxide. So how we can test? That means reaction is carrying out, so the gas is evolving. That gas, if you are bringing a burner or candle near or matchstick near to that test tube, we can hear that pop-up sound. So we can indicate that hydrogen gas is evolved. So zinc metal also react with sodium hydroxide solution to form hydrogen gas. Thus aluminum and zinc are two common metals which react with bases. So the two metals, that is an exception, means some metals react with bases. So that some metals means these two are metals. Aluminum and zinc are two common metals which react with bases to produce hydrogen gas. So in general we can say that some metals react with sodium hydroxide to produce hydrogen gas. Please note all the metals do not react with bases. So note only some metals will be reacting with bases. So metal plus base gives hydrogen gas and salt. Only in the case of some metals like aluminum, zinc. Most of the metals do not react with bases. So some non-metals react with bases. Even some non-metal also will be reacting with bases like sodium hydroxide, but no hydrogen gas is produced. So the reaction of non-metals with bases are complex. We will be study this in higher classes. So metals, most of the metals will not be reacting with bases, but some metals like aluminum and zinc will be reacting. Okay, the next topic we are going to study about the reactivity series of the metals. So that means so many of the metals are more reactive, like we know sodium, potassium, that are the highest reactive metals, and some metals are less reactive. So that we'll be studying in the next class about the reactivity series and all. Okay, thank you.